So we're going to talk about Ruby arguments today. As we said, I'm Schandorf. On the Twitters, I'm Nerdy Teacher, because I used to be a teacher for 15 years. And since I'm super nerdy, I threw the 3 in there. But now I'm a developer, and while I love being a teacher, I'm super grateful to have my second career. And I don't even miss my summers off. I work at Stack. We're an ad tech data aggregation company in Baltimore. My colleagues are here at the table. They can probably give you a much better explanation of what we do than I can. Ruby for Good is my favorite event, and I look forward to it all year. I'm helping to organize Code for Good this year. It's in Portland. It's a spin-off of Ruby for Good, but we're using Python. I'm also helping to organize WeCamp. It's a fill-in for DCamp this year. It's a pair programming and unconference in the woods for Rubyists. It's a ton of fun, and we have great people that come. So if your company is interested in getting involved with us in this great community, please get in touch with me. Or if you just want to hear more about any of these events or talk to me about them, that would be great. Come and stop by and talk to me this afternoon. So today we're going to talk about 2 paths. We're going to talk about the happy path. And we're also going to talk about what happens when you've learned a little bit and you have a great plan. You start executing that plan, and it turns out to be not such a good idea. So first of all, raise your hand if you've heard of Minaswan. Awesome. So for those of you who haven't heard of it, Yokohiro Matsumoto is the creator of Ruby. We very fondly call him Mats. He's a super kind and humble person. When he was asked, he said he created Ruby to make developers happy. And that's carried into the community. In the early days of Ruby, if people in the community were being turds to each other, someone would jump in and say, "Hey, Minaswan," which is short for Mats is nice, and so we're nice. So it created this great community of super nice people who are friendly to newbies and who have created lots of space for people to enter the community. I was grateful to have this language and the wonderful community that came along with it. And I was lucky enough to be a team lead at Ruby for Good this year. And the swag that they gave us as team leads was super creepy. I mean super awesome. This awesome Mats pillow. And this side's even more creepy. And I know you're like all super jealous, so make sure you run and sign up for Ruby for Good this year and be a team lead so you can get whatever creepy swag they decide to give next year. I love Ruby, and I love that it's so flexible, and that we have so many ways to do things. It's really cool to be able to learn new ways to do things. I was being mentored by my then CTO, Mike Sabelski. He's awesome. I know lots of you have heard of him. He introduced me to some of these concepts, and I became fascinated with them. I wish I'd learned more about them earlier, so I want to share them with you today. We have lots of methods in Ruby, but they aren't all created equally, so let's take a look. So we'll start with the arguments most of us are using the majority of the time. Just plain old positional arguments. A positional argument names the input based on the position of the input. So let's start with the pros. Positional arguments are super simple to set up, and for positional arguments, we can just name the params in the function definition, and when we call the function, we name the values in that same order. This works really well, especially in simple cases where it's likely intuitive what the params would be. Since they are so commonly used, and they look so familiar, and they're easily recognizable. So the key with positional arguments is position matters. So anytime we call this function, the first argument will always be name, the second argument will always be for length, and so on and so forth. All right, so let's look at some of the cons. Since the position matters, we have to be very careful when listing the params in the function call. We have to look at each param and make sure they line up in order. So here I have a function that takes a bunch of arguments about my cat and gives me a sentence that makes the cat Pi has gray fur that is short and small in size with a temperament characterized as spicy. That's my cat Pi. This works really well if I remember the order, but it goes terribly awry when I mix up the order, and I wind up with the cat honey has skittish fur that is brown and long in size with a temperament characterized as large. That's sort of my other cat honey. All messed up. Positional arguments don't give us great error messages. They don't give us a clue as to how to fix the error. So if I'm going through my arguments and I miss one, I just get told I gave 4 arguments, but I needed to give 5. So which one is missing? I'll have to go through and pair them up and figure out what I'm missing to make sure I get it in the right spot.
Better than JavaScript.
Very true. So if you're working with this function and you've forgotten that you need to have a temperament, then you could be looking at this for a while trying to figure out what you're missing. When you find it, you also run the risk of adding temperament into the wrong spot. Depending on how big your code base is, this might not be a very big deal, especially if you've got great test coverage, which we all have, of course. But say you have this code for a shelter you're running, and you have this function, but then people are looking to adopt cats, say they want to know about their temperament and their size. So you go and you add this in. But now you'll need to refactor every time you call this method to now include temperament and size. And you might not care about these features every time you call the function cat, but they'll still always be required. So to recap, positional arguments are simple to set up and are most commonly used, but order matters, error messages aren't super helpful, and adding arguments forces us to refactor. So we can do better than that. We can add an argument with an empty hash assigned to it, and when we call the function, we can add whatever keys and values we want. This is what we call an optional hash. Or we can add a value to the argument when we define it. This is a default value. Here we have assigned breed and legs as default values. So we get those for free anytime we call this function. Default values and option hashes are both examples of optional params. So again, we'll start with the pros. Optional params are very flexible. So if you have a default value, we get those for free. But if we want to override them, and our new cat is now Siamese and only has 3 legs, poor thing, we can overwrite those default values. Optional hashes are very flexible too. Here we have a function that takes an options hash we call options. It's a very creative name. We could call the function with just a name, because that's required as the positional argument. Or we can call it like here, just with the name length and fur, name and fur length, sorry. Or we might want to call it with multiple values, as in our last example, where we have name, fur length, temperament, and size. Each time we call it, we get to decide what we want to pass in. Another benefit of optional params is if we decide we need a new param in a particular instance. We don't need to refactor any other code. So if in a particular instance we also decide we want to have age, we could just add that in as a key value pair to the hash, and it wouldn't affect any other code. No refactoring required. So in this instance, we don't need to provide temperament, size, or anything else. Here we only want fur length, so that's all we need to supply. If we're using default values, we only need to provide the params we want to override, and the positional arguments, of course. So let's move on to the cons. So let's say you're working in a code base and you want to use this function. What options are you going to pass in? There's really very little information here. Again, we don't have all the information we need to make the function work properly. We could go and look at the body of the function and see what variables are being used and what needs to get passed in. And if your testing coverage, again, is really good, then that'll certainly help. But it sure would be nicer if we had more information clear up front. All the keys and values are stored as a hash here, so it takes a little bit of work to get it pulled out into variables available for us to use in the function. We can simplify this with destructuring, which we're going to talk about next. So if color is the optional param, you can see I can just call it like this. But then my friend Julian, he's from the UK, so he will also add in color to the options hash, but he spelled it wrong. I mean, different. He spelled it different. So this can be difficult to debug because it will just look like he never passed in color. And poor Julie may be staring at the screen for a long time to figure out what exactly went wrong. So let's sum it all up. Optional params are very flexible and easily extendable. We don't need to refactor. And when we add to it, we only need to supply the params we need. But it can be confusing. Sometimes our optional params turn out to be not so optional. And it's cumbersome to pull the arguments out of the hash. And typos are super hard to debug. So next we're going to look at destructuring. Destructuring allows us to set multiple values to variables at the same time. Bless you. So we'll start with the pros. If we assign the values in parallel, it's definitely more simple. It's more efficient code. Destructuring is easy to read. When we call each on a hash, we would normally have to pull out all the values for key and value and assign them to variables. But with destructuring, we can name them both key and value inside the pipes, so they're already assigned to their respective values inside the block. Here's another example of destructuring. It's called parallel assignment. If we're really clear, it's really clear to you what's going on. The code is really easy to follow, and the first variable corresponds to the first value, the second variable corresponds to the second value in the array, and so on and so forth. Do you remember our optional parameters code we looked at just a few slides ago? We had this options hash, and we had to assign all the instance variables and pull them out of the hash. I told you we could do better than that, right? So let's look. So we can use destructuring here and call values on the hash. So we can use parallel assignment to clean up this code and make it more clear. We can also use destructuring with blocks. Here we have an array with 3 arrays inside of it. And instead of passing the array and then pulling the array apart, destructuring allows us to pass them in with the structure and give naming assignments as it's being passed in. Pretty cool. So let's move on to the cons. So it doesn't fit every situation. Destructuring can become like a hammer in your tool belt that starts to make every situation look like a nail. And you want to turn your code and make it work so you can do this cool thing that you learned. But sometimes it's good to remember that you have other tools in your tool belt. Positional arguments, destructuring, keyword arguments, which we're about to talk about, are all other tools. And so using the right tool at the right time is the key. So if you have something super simple like this, it really doesn't make sense to use anything other than a positional argument. So let's recap. Destructuring simplifies code. It's easy to read and super clear to the caller. But it's not the right tool for every situation. So Ruby 2.0 brought in keyword arguments, which brings hash syntax into arguments. So again, we'll start with the pros. Until Ruby 2.0, we only had positional arguments and optional hashes. But now we have keyword arguments, so we can create a function like this. We need to use the keyword when we call the function, which can feel a little verbose. But it's super clear to the caller and the reader what the params and the values are. Excuse me. When we have a bunch of arguments, we can call it just like we do a hash, so it looks a little more clear. When we call our cat function, but we accidentally miss the keyword size, we get this lovely error message. This is my favorite. And it reminds us, hey, you need size. Please add it in. Not just, you're missing something. Go figure out what it is. We can use default values. So we only need to pass in the params we want to change, or not defaulted when we call the function. This makes it super structured, yet still quite flexible. So let's talk about the cons. Depending on how many params you have, they can start to feel very laborious. But we can fix this by formatting it nicely like a hash. But be aware that it might not be an indication. It might be an indication of a code smell, and it might be time to start thinking about creating an object. Keyword arguments only work on Ruby 2.0 or greater. So if you're working with a government or some other legacy system, chin up. You can look forward to using keyword arguments in 10 years or so, right? Okay, so something to look out for with keyword arguments. Keep an eye out. One gotcha we have with keyword arguments is if you don't notice that they're keyword arguments, you're just not paying any attention, and you try to call it just like you would positional arguments, you get this really funny error message that tells you you gave 5 arguments and it didn't expect any. And so you can sit there and look at that for a little while thinking, I know I'm supposed to have arguments, I see it right there. So you always, and lastly, you also want to make sure you always put the keyword arguments at the end, or the interpreter could get confused. So to sum it up, keyword arguments are clear, give us excellent error messages, and we only have to supply the params we need. But it can be quite verbose and only works on Ruby 2.0 versions and higher. So lastly, we're going to look at splats. Splats allow us to receive an undefined number of arguments and give us some flexibility with the types of arguments we've already talked about. So rather than talk about the pros and cons of splats, we're just going to talk about how we can use splats with the types of arguments we've already looked at today, and maybe see some fun tricks we can use. Splats allow us to receive an undefined number of arguments, so we can call the function with however many arguments we want. It's kind of cool. So we can use splats to do some grouping. So, like if we only care about our first and our last values here, we can just sort of group the rest of them together. We can also do this with an array or a function. They operate exactly the same. So that's kind of cool. Here's a clever and fun way to use destructuring with splats. Let's say you have a very strange family, and they come into the shelter you're running and they say they want to adopt the youngest and oldest cats you have. No problem, we can write some code for this and figure out which cats to bring them. So we write this min-max function. We use destructuring to return our min and max values, and then we just have to pass in the ages of our cats to find out that our youngest cat is 3 months old and our oldest cat is 11 years old. So if we use a splat, we can use positional arguments to pass in any number of arguments. But what's really cool is we can also call the same function with keyword arguments. So if we've got a hash of key values, pairs inside the function. So that's it. That's all I have. Thank you so much for your time. Any questions? Yes.
You mentioned Ruby for Good.
Oh, okay. I'm so glad you asked. So raise your hand if you've ever been to Ruby for Good. Woo! That's awesome. So Ruby for Good is a weekend-long retreat type-like thing. We stay on this beautiful campus. Look how gorgeous that is. We have a serene setting, and we hack on projects for nonprofits. It's really awesome. We have dinner together, we socialize together. After dinner, we stop working on the projects. We play games, we sing karaoke. If you're lucky enough for Casey to come, he'll do some dance lessons. Woo! And we just build some community. You can meet your mentor there, you can build friendships, several people have gotten jobs, so it's just a really nice place to go and build that community. It's truly an amazing experience, and I hope to see all of you there next year. I think this year we sold out in like 10 days, so it's pretty competitive, and I know you want some of this awesome Minneswan swag, so make sure you sign up early and sign up to be a
team lead.
Team lead. Thank you. All right, thank you very much.